This project is based on monitoring and control system designed for the soil moisture sensor. With the help of this project, the soil moisture can be monitored from anywhere around the world using Node MCU ESP8266 Wi-Fi module and Blink application. In this project, two-way communication is used. We can monitor the water content present in the soil in real time, and we can also control a solenoid valve. Higher the value on the gauge means the soil has less moisture. At this point, we can turn on the solenoid valve. As you can see, the value on the gauge is decreasing. Once you are satisfied with the moisture value, then you can simply turn off the solenoid valve. If you're working on the moisture sensor for the first time, then I recommend you should watch my Getting Started tutorial on the moisture sensor, in which I explained all the basics, including the moisture sensor modes, digital and analog, the purpose of the potentiometer and LEDs, the basic circuit connections and programming, explaining everything. I will provide a link in the description. Without any further delay, let's get started. The components that we will need for this project are: number 1, Arduino or Mega. The same program which is written for Arduino can also run on Mega without any change in the code. Number 2, FC-28 soil moisture sensor. Number 3, 12 volt normally closed type solenoid valve. Number 4, 12 volt SPDT type relays. Number 5, 2N2222 NPN transistors. The left leg is the emitter, middle one is the base, while the rightmost leg is the collector. Number 6, 10K resistors. Number 7, Node MCU ESP8266 Wi-Fi module. Number 8, 5x7 cm Vero board. Number 9, 470 microfarad capacitors. We will need 2 of these. Number 10, female DC socket. Number 11, 7805 voltage regulator. First leg is the input, middle one is the ground, and the third one is the output. Number 12, LED. The longer leg is the anode and the shorter one is the cathode. Number 13, 330 ohm resistor. Number 14, female headers, and finally some jumper wires. These components can be purchased from Amazon. The components purchase links are given in the description. This project is based on my previous 2 tutorials. In this tutorial, you will learn how to install the Node MCU ESP8266 Wi-Fi board, and how to download and use the Blink library, and how to fix the USB UART driver error. While in this tutorial, you will learn how to make a power supply for Node MCU ESP8266 Wi-Fi module so that it can be easily powered up using a 12 volt adapter or battery or a power bank. The tutorial links are given in the description. This schematic is designed in Gatesoft Eagle 9.1.0 version. If you want to learn how to make schematics and PCBs, then watch my tutorial. The link is given in the description. The Node MCU module TX and RX pins are connected with pin number 2 and pin number 3 of the Arduino, while the VN pin of the Node MCU module is connected with the output of the voltage regulator. This is a regulated 5 volt power supply based on LM7805 voltage regulator. 2 470 microfarad capacitors are connected at the input and output side of the regulator. A 330 ohm resistor is connected in series with a 2.5 volt LED. This is a current limiting resistor, while this is a DC female socket. Over here you can connect a 12 volt adapter or battery. But you can also power up the Node MCU module using your laptop USB port or a 12 volt adapter. But in my case, I'm going to use a power bank. The soil moisture VCC pin is connected with Arduino's 5 volt. The ground is connected with the Arduino's ground, while the A0 pin of the moisture sensor, which is the analog output pin of the moisture sensor, is connected with the Arduino's analog pin A1, while the digital output pin of the moisture sensor is not connected. While these two pins are connected with the two-legged lead. These two relays will be used to control the solenoid valve and the water pump. For controlling these relays, we will need relay drivers. The relay drivers simply consist of the 2N2222 NPN transistors, 10K resistors and diodes. As you can see, a 10K resistor is connected with the base of 2N2222 NPN transistor. It's a BJT, bipolar junction transistor, a current control device. That's why we need a current limiting resistor. We usually use a 10K resistor. The emitter of the 2N2222 NPN transistor is connected with the ground, while the collector is connected with one side of the relay coil, while the other side of the relay coil is connected with 12 volts. This relay can be energized and de-energized using this transistor. As you can see, this relay consists of 5 pins, 2 coil pins, common, normally closed and normally open. These 3 pins have no physical connection with the coil pins. In my previous tutorial based on home automation using Node MCU and Blink application, I've explained this in very detail. And in that tutorial, I also explained how to connect a lamp or any other load with the relay's output. The link is given in the description. All the connections are exactly the same. These are freewheeling diodes used against back EMF protection. This is the moisture sensor. Its VCC pin is connected with the Arduino's 5 volt. The blue wire, which is the ground wire, is connected with the Arduino's ground. The yellow wire is connected with the analog output pin of the moisture sensor and is connected with the Arduino's analog pin A1. This is the Node MCU module. Its ground pin is connected with the Arduino's ground. Its TX and RX pins are connected with the Arduino's pin number 2 and pin number 3. The Node MCU module can be powered up using the power bank, or it can be connected with the laptop through a USB cable, or you can connect a 12 volt adapter over here. This is a 2-channel relay module. These relays are connected with Arduino's pin number 12 and pin number 13. And over here, we connect 12 volt for the relay module, as these are 12 volt ESP8266 type relays. Later I will connect a solenoid valve. Now let's make a Blink application. First of all, open the Blink application. Set the project name as soil moisture. Click on the choose device and select Node MCU. Make sure you set the connection type to Wi-Fi. Then click on the Create button. An authentication token will be sent on your email ID, which will be then used in programming. Simply copy and paste it in programming. Now save the program. Make sure you select the correct Node MCU module. Click on the Tools menu and make sure the right COM port is selected. And then select the correct Node MCU ESP8266 Wi-Fi board. Then you can click on the upload button and wait for a while. Now let's get back to the Blink application. Click anywhere on the screen and search for the gauge and add it. Click on the gauge and set the name as soil moisture. Now click on the pin and select virtual and select V2. Now click over here and make sure it is set to 1023. Change the font. Click on push and select 1 second. Now click on the screen and add two numeric input buttons which will be used for controlling the solenoid valve and water pump. Click on the numeric input. Set the name as solenoid valve. Click pin and select the virtual pin 10. Set the minimum value to 10 and the maximum value to 11. These 10 and 11 values will be used to control the relay connected with pin number 13 of the Arduino. Now repeat the same steps for other numeric input button. Our basic application setup is completed. Now let's discuss the programming. This project is based on two programs. This program is written for the Arduino and this program is written for the Node MCU ESP8266 Wi-Fi module. First, let's discuss the Arduino programming. Hash includes software serial.h. This is the library that will be used for making a serial port on pin number 2 and pin number 3 of the Arduino. Using software serial library, we can define multiple serial ports. Software serial node MCU 2, 3, 2 is the RX and 3 is the TX. Integer M sensor is equal to A1. Moisture sensor is connected with the analog pin A1 of the Arduino. Integer MS value is equal to 0. This is a variable of the type integer and will be used to store the value of the moisture sensor. Long integer data, the variable data, will be used to store the value received from the Blink application. Integer relay 1 is equal to 13 to control the solenoid valve. Integer relay 2 is equal to 12 to control the motor or anything else you want to control. Integer is data 1 is equal to 0. Finally, the moisture sensor value will be stored in is data, which can be then added with a string. String CData. CData is a variable of the type string. This variable will be used to make a complete string message consisting of the sensor value. As you know, my friends, every Arduino and Mega program has at least two functions, which are the void setup and void loop function. Void means that this function is not returning any value, while the empty parentheses means that this function is not taking any arguments as the input. One more thing about the void setup function and void loop function is that the void setup function executes only one time when the Arduino is powered up, while the void loop function executes again and again. Serial.begin 9600 activates the serial communication at baud rate 9600. This will be used for the debugging purposes. Node MCU.begin 9600 activates the serial communication with Node MCU, which is connected with pin number 2 and pin number 3 of the Arduino, and 9600 is the baud rate. Pin mode is a function and it takes Two arguments is the input, the pin number or pin name, and the status, which can be input or output. The sensor is set to the input while the relays are set to the output. Then starts a while loop function. If node MCU dot available equals 0, if we have not received any data from the node MCU module, then what to do? We simply read the moisture using the analog read function and store the value and variable ms value. Then using the serial.println function, the value is sent to the serial monitor for the debugging purposes. And then save the value and variable is data1. And then add the value of this variable with the C data and use comma as the delimiter for separating the sensor value. Then we send the complete message to the node MCU module and use a delay of 1 second, and then at the end empty the C data variable for storing new values. If node MCU dot available greater than 0, if we have received any data from node MCU module, which happens when we press the numeric buttons in the Blink application. Data is equal to node MCU dot parse integer, store the value and variable data. Then we use if conditions to compare the received value and then turn on and turn off the desired relay. If 10, then relay 1 low, if 11, relay 1 high, and similarly for the other relay. Now let's discuss the node MCU programming. Before you start the node MCU programming, first of all make sure that you download all the necessary libraries and you install the node MCU board, and you also install a driver for the USB UART. I have a separate video on this, the link is given in the description. These are the 4 variables of the type integer which will be used to store the values sent from Blink application. I'll be using pin value 1 and pin value 2. This is the authentication number which was sent via email. I simply copied and pasted over here. This is the name of your Wi-Fi and this is the password. String my string. This is used to store the complete message which is received from Arduino, which consists of the sensor data. Character or data. Our data variable is used to store each and every character which is received serially from the Arduino. Integer first value. This is a variable of the type integer and will be used to store the value of the moisture sensor which is received from the Arduino. This function sends Arduino's uptime every second to the virtual pin 1. In the app widgets, reading frequency should be set to push. This means that you define how often to send data to the Blink application. Sensor value 1 is a user-defined function which is called every 1 second. We can change this time. Then starts a while loop function. If serial.available equals 0, this means if we have not received any data from the Arduino, then simply keep executing these functions. If serial.available greater than 0, which means if the node MCU module has received data from the Arduino, then simply read the serial monitor, add the received characters with variable myString to make a complete message. This condition makes sure that the entire message is received. Then we split the message using the comma as the delimiter and access the value of the moisture sensor and store this value in variable L. And then convert this value into integer and store the value in variable first value and then empty the string for a new message. Sensor value 1 is a user-defined function and we use this function to send value to the Blink application. As you can see, the first value is stored in sData and then the sData is sent through blink.virtualWrite function to the virtual pin V2. This is a user-defined function of the type string, and it takes three arguments as the input: the data, separator, and index. This function is used to split the string. In Blink application writes values to the virtual pin 10. This instruction assigns the incoming value from pin V10 to a variable. This instruction is used to send that value to Arduino, and similarly for the virtual pin 11. Now we are done with the programming. I have already uploaded these programs. Let's watch this project in action. All the components are interfaced as per the circuit diagram. Then I checked the solenoid valve using the application. Everything is perfect. I can monitor the moisture value and also control the solenoid valve. Now let's turn on the solenoid valve. As you can see, a decrease in the value, which means that the water content in the soil is increased. When you are satisfied with the value, then you can simply turn off the solenoid valve. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.